Good morning, grade nines. We are back again with our natural sciences. It's Friday today. I'm hoping and believing that everyone is as happy as I am. I am still your host, Olisan Mbata, and you can find me on these following social media handles on Twitter at MbataX or on Instagram at XKIM. Just to recap before we get to today's lesson, since last week Friday, we went on to Monday and we went on during this week. We've been on our we've been doing, we did forces. After forces we did resistors. After resistors we did the materials that affect resistors, the length, and we moved on. I hope people still remember that we've got forces, and then that forces act in pairs. And then we also dealt with the types of forces. And then we also mentioned that we've got contact forces. We also did field forces. We moved on to do magnetic and non-magnetic material. And then we finally came to electric cells as energy systems. Then we moved on to what you call resistance. We did types of resistors. To mention a few, we spoke of a conductor, we spoke of a resistor, we spoke of rheostat, we spoke of a diode. We all know what are diodes by now. We also spoke of a voltmeter and an ammeter. And then we also spoke about factors that affect resistance in a circuit. And then today we are going to deal with what exactly is a circuit. Today we are going to deal with what exactly is a circuit, grade nines. By the end of today's lesson, grade nines, you are going to learn the following. You are going to learn how to analyze data and draw conclusions. I decided to move that section of analyzing data and drawing conclusion for later on in our lesson. But I want you to actually look at the series circuit. So now, before I actually introduce you to series circuit, what I want you to know as a grade 9 learner is simple. I want you to know and understand the term circuit, because for most of the week we've been talking about the current flowing from the cell. We've been talking about resistors in the cell. We've been talking about how we connect a voltmeter and also ammeter in a circuit. All these things we've been discussing. Okay, grade nines. And finally, we're going to have a nice homework. I believe everyone is going to enjoy it. I also enjoyed planning it. So I'm hoping you all enjoy. So grade nines, who wants to assist Mr. Mbata with yesterday's homework? You may raise up your hand. First come, first serve basis. Mate 20, yes, you can open your mic. Let us work. Mate 20 raised the hand first. Can we do the corrections together? I don't know who's using a Mate 20. It doesn't have a name, so I saw Mate 20.
Morning, sir.
Morning, how are you?
Good morning, sir.
And your name is?
Esther.
Okay, Esther. Esther, we are going to do the corrections of yesterday's homework. So the first part of the homework is very, very simple, Esther. You're just going to do what? You are going to help me define these terms. First term there, it's resistance. What is the definition of a resistance, Esther?
Resistance is the ability not to be affected by something.
Resistance. So in a circuit, what are we talking about when you're talking about? We're talking about the flow of electric charges, right? So we are going to phrase it like this, Esther. We are going to say a resistance is an electrical quantity.
Electrical
A young one who
resistance.
also wants to participate there, Esther. Is an electrical quantity that measures how a device
So,
or material reduces the electric current flow through it. Flow through it. Okay, Esther. What is a diode?
the diode is like an electronic component to electrode that like let current flow in one direction.
A diode too allows or works best when the electricity is flowing through one direction. So a diode is defined as a two, so is a two terminal. Is a two terminal. So that means it has two terminals. That two terminal electronic. It's a two terminal electronic component. Remember yesterday, grade 9, we did say that a diode is a special component of a resistor. So it's a two terminal electronic component that only conducts current conduct current in one direction, one direction. It allows it allows a current to flow in one direction so long as it is operated within specified voltage. So it needs to be it needs to operate in a specified. It operates in a specified voltage. Specified. So it is very specific. Remember that we said we use this as specified voltage. Remember that I said to you yesterday, we need to actually put what you call, we need to, the diodes are mostly found in traffic lights. So Esther, what is a rheostat? Esther?
So can you hear me?
Yes, I can hear you now. So what is a rheostat?
It is a variable resistor which is used to control current.
Yes, it's an electrical instrument used to control a current by varying the resistance. So it's an electrical instrument, and electrical instrument used to control what you call a current. So that means the flow of current by varying. So this is differentiating or making it more or less the resistance. So you are controlling how much current is going to pass through via the rheostat. E.g., which one you can use as your example? Where do we use our resistance? A rheostat. So you would say, for an example, will be your radio volume. So it is that an example of a rheostat. Radio volume is you are using a rheostat volume, and there are more other examples that we can actually mention. The last one, grade 9, tell me, what do we use? What are resistors used for, grade 9? What are resistors used for?
Resistors are used to like reduce current flow
Yes,
and
that will be
to
one,
divide
to reduce
current,
current flow, and
to divide voltage.
It also divides voltage. True. Divide voltage. That will be your obviously another use of a resistor. Another one maybe.
Adjust single adjust signal level. Yeah.
Yes, it adjusts signal level. It adjusts signal level. Then there are other examples that you can actually involve their grade 9s, etc, etc. Esther, let us move to the second part of our homework. That was very, very nice. That was very, very nice. And then here you were supposed to actually say whether your statement is true or false, grade 9. You need to state whether the following statements are true or false. So the higher the resistance, the lower the current. Is it true or false?
It's
Hello?
false.
Huh? The higher the resistance, the lower the current. Is the statement true or false? Anyone can open a mic. I think I've lost Esther. Anyone can open a mic there and talk to me.
So it's
The
true.
weekend.
The answer is true. Is that Amra?
Yes, sir.
Okay, Amra, let's work. Yeah, the answer is true. Why grade 9 is the answer true is because remember that the current, the resistance is opposing the flow of current. So that's why you cannot say if there's the higher the resistance, the higher the current. So if the current is higher, that means if the higher the resistance, if the resistance is higher, the current flowing through will be less. However, if the current is higher, that means the resistance is low. Amra, copper,
Yes.
silver, and gold have more resistance than nichrome.
False.
False, because yesterday we spoke and said that copper, silver, and what you call and gold are good electricity conductors, but the problem is that they are very
Low in resistance.
they are very low in resistance. They are very expensive. That's why we don't use much of them. Then
Yes.
Amra, again, let's look at that one there. They say to you, the longer the conductor, the higher the resistance.
True.
Yes, it is true. Remember when we were actually discussing yesterday about factors that affect the current flow, we did speak of what you call of
The longer the conductor.
of the length of the conductor there, that the further you run, the more tired you get. So obviously, the further the charges or the current flow through the conductor, they will get tired as well. So they say to you, the Amra, the thicker the conductor, the higher the resistance.
False.
The thicker the conductor, the higher the resistance. The correct answer
False.
is indeed false. We know, we even made an example of a hose pipe yesterday, that the bigger the hose pipe, the more flow of water through it. So the correct answer is false. Then grade 9s and Amra there representing you. Let's do the last one. The hotter the conductor, the higher the resistance.
True.
It is true. That means the energy is being utilized before reaching the destination, and then the kinetic energy is being wasted there. Thank you so much, Amra, and please do join the lesson. Don't go away. And then everybody else, remember that immediately after this lesson, you will get the slides and the video live on YouTube, and the slides are available on www.africatincake.co.za. You click Natural Sciences Grade 9. But now I want us to focus on today's lesson, Grade 9. I'm not sure if you can see, but I am sure you can see. Actually, I am sure you can see. Grade 9, those are examples of the series circuit. Look at the following circuits, grade 9. They might not be very, very big, but you can see them. Look at my cursor there. Yes, you can see the cursor is big. I want us to focus on this circuit number 2 there. You can see where my cursor is. That is a cell. It has a 1 cell. So the longer one there is the positive charge, and the shorter one is the negative charge. So the energy, when it flows, it starts from the negative side, going through the conductor to the resistor, going up to the resistor. So these resistors, if we may see these ones, these zigzag, I'm calling them the resistors because obviously they are utilizing energy. So they are connected in series. When we're talking about things that are connected in series, grade 9, it's like they are in a chronological order. They are following one another. You know, I am not sure if in mathematics you've done sequence and series. You will know that a series, it's when you say 2, 4, 6, 8, 10, or 1, 2, 3, 4, 5, 6, 7. There is a series of the numbers following each other. So same applies when we say the objects are being connected in series there. We are talking about how they are following each other. Let's say there is a resistor here in a first bulb. That means the energy distributed, the energy distribution will obviously be not equal. Now it will not be able to go through. Are we clear, grade 9? I am sure that you've seen the example of the circuits that are everything here on this page. It is connected in series. You can actually go to the slides after the class and zoom in these different what you call circuits. You will see what I'm talking about. So we've got types of circuits, grade 9. So if we've got types of circuits, but what I want you to know is that we've got different types of circuits. So for us having types of circuit, it means we've got different types of circuit. For example, what are we talking about when we're talking about a closed circuit? When we're talking about a closed circuit, grade 9, we are talking that this circuit has a complete path for current to flow it. So there is no open switch, or there is nothing that will prevent energy from flowing from one object, from one bulb to another, for example. So the circuit is closed. Then when we're talking about an open circuit, grade 9, an open circuit, grade 9, is simple. It means it is the opposite of the closed circuit. An open circuit doesn't have a complete path for current to flow, which it means that it is not functional. So that means if there is a what you call, if we've got an open circuit, some of the bulbs will get the energy, some of the bulbs won't get the energy. Unlike in a closed circuit, here in a closed circuit, the energy is guaranteed to flow everywhere. Are we clear, grade 9? Are we clear, grade 9? Then we've got another type of what is a short circuit. If your daddy sometimes, you know, finds that you are watching TV there, and then the switch trips there. The switch trips, and then your daddy goes and says, or your brother or your sister, whoever is more clued up with electricity, will say to you, oh, there's a short circuit in this house. I wonder what causes it. And then they will say, take off the kettle, or take off
Sorry, breaking
the
up.
or take off whatever, the stove even. And then because a short circuit is a low resistant path, which usually is made unintentionally, that bypasses part of a circuit. So this happens when two bare wires in a circuit touch each other. Remember that we said copper is used to transport, or yes, the charges from you use a copper as a what you call a conductor. So the cord, for example, of your kettle has wires inside them, and these wires are insulated with plastic or rubber, which is an insulator covers that copper. Remember, to actually avoid this short circuit. But if these two coppers from these wires that are working as conductors touch each other and they do not have insulator, we are going to have a short circuit. That's why our main switch will trip, or that's why our kettle will stop working. So now you know what is an open circuit, you know what is a closed circuit, and you know what is a short circuit and what causes a short circuit. Grade 9. As I'm continuing grade 9, if you have any question, you have every right to actually raise up your hand and ask a question. Again, let us look at the series circuit now. I want you to understand the series circuit. I've shown you a picture of a series circuit. I said everything follows each other. Remember, we said even the cells are connected in series. Remember that we said the cells are connected in series. Look at this, grade 9. Look at this, the very first circuit here. You see this has two cells. You've got a longer one, the shorter one, the longer one, the shorter one. And then remember that a cell is made by a longer one and a shorter one. So here we have 2 volts of cells. From these 2 cells, we're getting 2 volts. And then we continue like that. So they are series. They are in series because they are following each other. They are following each other. Yes, do you have any questions? I see 2 participants raise their hands. Do you have any questions, guys? Okay, I'll take it as if it was a mistake. So in series circuit, grade 9, please bear this in mind. Take this with you. In series circuits, the same current flows through all the components. In series circuit, the same current flows through all the components. The same current flows through where? In the series circuit. The total voltage across the circuit is the sum of the voltages across each component. And the total resistance is the sum of the resistance of each component. Grade 9, this is it in a formula. If I say to you, calculate the voltage for this, you will say voltage 1 plus voltage 2 plus voltage 3, because they are following each other. They are equal, they are used everywhere. So the total voltage is the same voltage is the sum of all the voltages across the component. And then the resistance, there's the resistance, which is R. It is also the sum of all the resistance of each component. If we've got 3 bulbs, we're going to count it like this. And if we've got 6 bulbs, we are going to count until 6, until so on and so forth. Grade 9s. Are we clear, grade 9s? Any questions? Then now we've got the parallel circuit. I said to you, number 1, we've got an open circuit, we've got a closed circuit, we've got a short circuit, we've got a series circuit. And then now I'm talking about a parallel circuit. We say wires have the same voltage applied to them when you're talking about parallel circuits. However, different amount of current flowing through them depending on the resistance of the individual wire. Remember, on the series circuit, when we're talking about the series circuit, we said the current is the same, flows the current flowing through what you call resistance there is the same, but in a parallel circuit, the current is different. For example, parallel circuit will be the wiring system of your house. Each and every other household, grade 9s, is actually wired in a parallel circuit. Why is it that? It's because we don't want to say, if you don't get if we switch off the light at in the kitchen, therefore people watching TV, they are now going to be out of the light. That's why we are using the parallel wiring for our houses so that everything has its own independent current flowing to it. That means if the kitchen light is off, you can have your sitting room kitchen light on. If your bathroom light is off, which is almost always off, that means your bedroom light can be on. But if we were to connect our houses in series, grade 9, if our main switch is in the bathroom, let me say in the kitchen, if our main switch is in the kitchen and then I switch off the kitchen light, that means all the lights in the house will be off. That's how series work. Are we clear? That's how series work. And then, but with the parallel one, each room will have its own independency. It will have its own independency when it comes to lighting. But with the series, every other room depends from which the one which is closer to the source of energy. You cut one wire there, then the other one may not get the what you call the energy. When I'm showing you the connection of what you call the connection of parallel circuits, you will understand. But for today, I want you to actually focus everything in series circuit. Let us continue grade 9. A single electric power source supplies all the lights and the appliances with the same voltage in a parallel circuit. A single electric power source supplies all the lights and the appliances with the same voltage. If one of the lights burns out, current can still flow through the rest of the lights and the appliances. This happens with the parallel circuit. If one of the lights burns out, current can still flow through the rest of the lights and appliances. But with a series circuit, if one of the lights burns out, current can no longer flow through the rest of the lights and appliances in the house. That's why we want parallel circuits, because we still want other places or other rooms to get the current, even though the kitchen one is not working. However, if there is a short circuit, grade 9, what happens? If there's a short circuit, the voltage drops almost zero and the entire system goes down. Remember, I made an example when I was actually introducing you to a short circuit. I said when two wires they touch each other and the current is flowing through them and they are not insulated, the main switch will fall because it's a short circuit. That means the power of the charges will distract the entire system. That is the short circuit. So whenever the main switch drops at your house, when you are trying to plug, let's say, a kettle, or we are trying to plug a heater on during this cold season, then you will be experiencing a short circuit. It will not mean it now the house has changed, it is now connected in series, but it will now mean you have experienced what you call a short circuit. So the short circuit, they say voltage drops almost zero and the entire system goes down. That's why the main switch trips. Then grade 9, let us recap what I've just taught you now. We said that in series circuit, there is only one pathway for current to flow through. In parallel circuits, there is more than one pathway for current to flow through. You already know the standard symbols to draw a circuit diagram. Remember on Monday, I showed you signs of conductors, cells, bulbs, resistors, ammeter, and voltage. I showed you that. If you don't remember, you can actually, now everybody I think has my email address, and say, Mr. Mbata, may I please have Monday slides? I'll gladly forward them to you. So we can connect cells or resistors in series or in parallel. You know that by now. We can connect cells or resistors in series or in parallel. The way we connect cells or resistors has an effect on the other components in an electric circuit. We are still doing a recap. It's something that I've already explained to you. And we can use measuring instruments such as ammeter and voltmeters to give us more information about circuit. You know what voltmeter obviously measures. You also know what ammeter now measures. And then you also know how we connect these two measuring instruments. I explained them to you yesterday. Let us now focus on our in series, the series circuits, grade 9. Please take notes. It is important for you to know this. They're saying connecting cells in series. Why? Because cells are the source of electrical energy within an electric circuit. We all know that we get energy from the cells. Remember, we said that cells store our energy as a potential energy, and then the energy or the current, when it starts moving, it uses a kinetic energy. Never forget that, grade 9. We connect cells in series by connecting the negative terminal of one cell to the positive terminal of the next. So I said in your cell, the longer one is positive, and then the shorter one is negative. So you cannot have two long lines next to each other and two short lines next to each other. It will be incorrect. You have to have the long one and then the short one, the long one and the short one. So I can see that you know how to draw your cells. So they are always following each other because we said that they need to actually have energy distribution. And we said through the conductors, the energy starts moving from the shorter one. So the longer one, there's no energy moving backwards. I even made an example with the batteries. If you're looking at the battery, the remote control battery, you will see that how you put the batteries. You cannot have the back part connecting to other back part. You need to have the back part and the front part, and then the front part attaches to the back part of the cell, and then the energy can now be utilized. But if you are going to have a back part following the back part in your cells, you will see that your remote control is not going to function. Do I have any questions, grade 9s? So they say when cells, yes?
Yeah.
Yes. I'm listening. Okay, I think you people have a problem with your mics or something. Let me continue, grade 9. We say this means that the more cells you connect, the higher the voltage of the battery. Obviously, we said that if there's more cells, that means there's more current that is going to flow through. If there's less cells and there's more components that are using the energy, we are going to have less current now demanded. If you connect one bulb to a light bulb, you will see the brightness will not be as much as when you've got two cells. And then we can measure the voltage or potential difference of a cell by connecting a voltmeter over terminals of the cell to actually see that. A voltmeter is always connected in parallel, grade 9s. The voltmeter needs to be always connected in parallel. Let me see, let us see this one. We said cells devices devices that produce electricity by converting a chemical energy into electrical energy. Remember this from the first lesson, that cell devices that produces electricity by converting a chemical energy into electrical energy. It is important for you to understand this part. And then we said a voltage is the amount of potential energy. You all know what is potential energy by now. So we said amount of potential energy provided by a cell or used by an electrical component to move a certain amount of charge in a circuit, also called a potential difference. Esther. Yes, what's happening?
On your own, then you
Esther?
play until school time.
Yes.
I wanted to ask how many arms are in a circuit?
In a
circuit.
In a circuit. Okay. But remember that an ohm is a unit of what? Of a charge. It's a unit of a charge. So it depends on the voltage. It depends on we don't have a constant, a constant number of ohms, that we can say we've got so much ohms in a circuit, because an ohm is it's a unit of charge. It's a unit of charge. So you can
Sir, you're
calculate.
breaking.
Sir, I can't hear you, sir.
I'm saying to you, we cannot say we've got 20 ohms in a circuit, because we have to actually now calculate that, because remember that an ohm, it's a unit of charge. So we can use an instrument or a formula to calculate how many charges is a bulb using per second or whatever. We can calculate an ohm. Like, look at the following slide, grade 9. Okay, let's continue. You will see it, Esther, as we continue just now. Battery, we said a battery, there are more than one cells connected together, and a voltage is an instrument used for measuring a voltage between 2 points in an electric circuit. So grade 9, the question that Esther asked is a part of our homework. I'm hoping I wasn't moving too fast and you understood everything. Please get your pen and paper ready for our homework. So number 1 says to you, complete the following statements. If you increase the resistance in a series circuit, what happens? If you increase the resistance in a series circuit, what happens? Then number 2 says, electric current is measured in what? Electric current is measured in what? And then we have a light bulb with resistance of 2 ohms. Do you understand now, Esther? A light bulb with resistance of 2 ohms is connected to a 4-volt battery. What will happen there? What will happen? So they say to you, a light bulb with resistance of 2 ohms is connected to a 4-volt battery. So
Sir, I
now,
think you skipped C, sir.
huh?
I think you skipped C.
Oh, see, electrical. What is that? Okay, thank you so much. Let me check my notes. Electrical power is expressed in what? Electrical power. Thank you so much. Electrical power is expressed in what? So when we're talking about electrical power, is it expressed in watts, or is it expressed in volts, or is it expressed in amperes? What is an electrical power expressed in? But for number 4 or D there, I want to know, a light bulb with a resistance of 2 ohms is connected to a 4-volt battery. What is the current flowing? What is the current flowing through the circuit? What is the current flowing through the circuit there? There, what is the current flowing through the circuit? What is the current flowing through the circuit? I'll be with you, Amra, just now. Let us read E. Amra creates a circuit with 12-volt battery. It is a parallel circuit. So now I'm already introducing you to our Monday topic. Amra creates a circuit with a 12-volt battery. It is a parallel circuit with 3 branches, and each branch has a 3 ohm resistor. How much voltage drop to each resistor at each resistor on the circuit? You need to answer that. You need to answer that. Let us look at the second part of our homework. Do we have the second part? Yes, we have the second part. It is a quiz. It is a quiz. So on our quiz, grade 9, what do we call one path for current to flow? What do we call it? One path for current to flow. What is polarity? What is current flow? Advantages of series circuit. Example of series components.
So you're going too fast.
I'm still there, but you can still right there on the screen. I'm not moving the screen. I'm sorry. You need to, so with the quiz, it's just you're going to put the name of one path for current to flow. What is polarity? Current flow. What do we call a current flow? How does the current flow actually? I've been explaining that. And then also looking at the advantages of series circuits. Advantages of series circuit. Then you're gonna give examples of series component. Examples of series components. Disadvantages of series circuits. I've also been explaining that to you. Disadvantages of series circuits. And then you're also going to look at how do you see or how do you calculate in a series rules? What are series rules? So we have actually been explaining this now. Grade 9th, you've got a homework with you, and this slide will be up just before 1, and then the video will always be there immediately available on YouTube. I want to take questions. Do we have questions? The first part of the homework is this one. It starts here. Yes, Benny.
Sir, it's fine, sir. You already
Oh, you're here now.
Yes, sir.
Okay. Another one, just raise the hand. I can't see the name. Yes, you can talk to me. If you've raised your hand, you can talk to me. Open your mic and talk to me. Okay, since we do not have any questions, grade 9. Oh, Daniel Manocha or Manonga. Yes, Daniel. Daniel? Okay, Daniel.
Sir,
Yes?
can you please
Hello?
explain the formula again?
The what?
Formula.
The formula for?
Sir.
for the series circuit.
Yes, sir.
Okay, I'm trying to find it. I can't see it. But it was that one when we said R is equal to R1 plus R2 plus R3.
Plus R3, yes.
Yes, and then for voltage, we said V1 plus
V1
V2
plus V2 plus V3.
Yes, so that is a series circuit rule, grade 9. So you need to know that. And
What about
if you,
parallel? What about a parallel circuit?
The parallel circuit, we're doing it on Monday. Remember, I've just introduced you with the homework there. That Monday, we're doing the parallel circuit. I don't want you to be confused. So I said there. Remember, that's what I've just shown you there. E says AMRA creates a circuit with 12-volt battery. It is a parallel circuit with 3 branches, and each branch has a 3 ohm resistor. How much voltage drop at each resistor on the circuit? So you need to actually now see about the parallel circuit connection, but it's not a plain smash. You will understand everything on Monday. Any more questions? Yes, Esther.
So what's the difference between a primary cell and a secondary cell? What's the difference between a primary cell and a secondary cell?
So the primary cell, it will be the cell that if the secondary cell will be receiving energy from. So the main switch of the house, it will be your primary cell, and then the second plug where you are plugging your charger in will work as a secondary cell, because it is also dependent of the primary cell, which is the main switch.
Okay, thank you, sir.
On that note, grade 9s, thank you very much. Please do your homework. If you've got any questions, don't forget to touch base with me. You know my social media handles. And again, you can also follow the school, STEM Digital School or STEM Lockdown Digital School, on these following social media handles. And I think you all have a great day. See you on Monday.
Bye, sir.
See you, sir. Bye, sir.
Bye, everyone. Bye, everyone. Have a great day.
Bye, sir.
Bye, Unkabeti.
Bye. Bye, sir.
Bye, Ngosi. Bye, everyone.
Bye, sir.
Bye, Benny. Bye,
So I
Amra.
have a
Bye.
question, sir.
Yeah.
So the ohms basically like the measurement of resistance, right? The ohms that were basically,
Yeah,
right?
and ohm is just an SI unit like Newton, like
Yeah, oh, volts, yes, like
yeah.
that, sir. Okay,
Yes.
thank you, sir.
Thank you. Bye.
Bye. Bye.